Welcome to the members of the organizing committee IAPT DSMA. So, uh, firstly, I would like to introduce myself. I am Dr. Shiva Udachan, Associate Professor, working at SS Techno Degree College, Gubi Colony, Kalburgi, in the Department of Physics. Now, about my academic qualifications. I completed my PhD from the Rani Chanma University, Karnataka, Belgaum, India. Degree was awarded on August 27th, 2021. Title of my PhD thesis is a study on electrical and microstructural properties of some metallic thin films. I have completed my postgraduate um, from CB College, Bhalki, in the field of solid state physics in the year 2013 from Gulbarga University, Kalburgi. I completed my Bachelor of Education with Physics and Maths specialization in the year 2011 from Gulbarga University. I completed my undergraduate course with a combination of physics, chemistry, and mathematics in the year 2009. Degree was completed. So now looking at my professional skills, I have a total of 11 years experience at UG level. So far, I have published 15 research papers in Scopus or Schemago. International conference presentations abroad, it is 12. Papers presented at the national international conferences or workshops or symposium within India, it is about 60. Participation in national or international conferences or seminars or workshops, it is 38. International conferences abroad as an invited speaker, that is 2. That is in for Ukraine and Portugal. So the international conference abroad paper presentation as well as oral and poster around 11 countries, namely Bulgaria, Hungary, Czech Republic, Portugal, China, Ukraine, Vietnam, Italy, Poland, Israel, and Taiwan. So I have the membership in the 4 academic bodies, namely as a life member IAPT. It was registered in the year 2013. Life member for Indian Vacuum Society, Mumbai, in the year 2014. As a life member for the Karnataka Rajya Vigyana Parishad in the year 2018. Life member for the Karnataka Physics Association, that is in the year 2012. Patents have been filed too. Among that, 2 patents, 1 patent has been granted, that is application number 2014-410-49633. Title of my patent granted is a method for aiding resistivity and energy gap measurement of semiconductors. And the second one which I have filed is a method and system for accurately calculating the thermal conductivity of a partially matched specimen. Date of filing is 17/2/2020, Indian Patent Office, Chennai. So the skills about my skills. Uh, okay, with reference to the above cited subject, I intend to place before you the following few lines regarding myself, Dr. Shiva Udachan. Uh, okay, for the suitability of the IAPT 2024. Okay, I have presented 2 research papers orally. Among that, 1 paper has been adjudged as an excellent paper by the guest editors and referee reports of 20th Jubilee International School on Condensed Matter Physics and Applications of Advanced and Multifunctional Materials held at Varna, Bulgaria, in the year 3rd to September 7th, 2018, and it has been published in the IOP Conference Series, Journal of Physics Conference Series. And the second paper, that is means awarded as outstanding work for oral presentation, entitled Base Pressure Effect of Electrical Properties of Chromium Nanofilms, mm, in at the International Advanced Study Conference, that is Condensed Matter and Low Temperature Physics 2021, 6 to 12 June 2021, Kharkiv, Ukraine. Okay. Next, I have been awarded second prize uh, for the on the title Low Cost Experiment for Proper Technique, that is at the regional competition of innovative experiments in physics held on July 10th, 2022 at Maharani Lakshmi Amani College Physics Lab, Science Post, Bangalore. I also been adjudged as a second place in the International Conference on Functional Glasses on November 13, 14, 2022 for celebration of International Year of Glass 2022, organized by Indian Association of Physics Teachers, IAPT Karnataka Regional Council Tool and Institute of Electronics and Telecommunication Engineers, IETE, Kalburgi, in collaboration with Karnataka Science and Technology Academy, KSTI, and Karnataka State Council for Science and Technology. So patents 5 so far is 2, 1 is granted and another is 5. Okay. Another achievement which about about my student. There is under my guidance, Ramya Suresh is awarded third prize in essay competition held on 24th August 2022 in connection with the DA Iconic Week celebration held at District Science Center, Kalburgi, in collaboration with Nuclear Power Corporation of India Limited, Mumbai, and Kaiga Generating Station. Certificates of the two most significant awards as per the assessment, and a list of others have been discussed so far. Now, okay, I've been selected to attend the 2023 ICTP Winter College on Optics, Terahertz Optics and Photonics Online. That is from 6 February 2023 to 7 February 2023, Trieste, Italy. I have been selected for as an invited speaker at the third International Advanced Study Conference Condensed Matter and Low Temperature Physics 2023 held on June 11, 2023, Kharkiv. And I also been invited as a speaker for the ANM 2023 during 26 to 28 July at the University of Aveiro, Portugal. Okay. My another achievement about my research work is I have published one article in the Vijnana Loka. That is the name of the article is Saur Shakti Igna Agatya. That is Samputa 18 Sanchike 1, page number 32 bi-monthly Karnataka Science and Technology Academy, KST Bengaluru. Okay. The I am having the practical experience and instruments operated, that is around 14. The following instruments have been operated by myself. First one, thin film vacuum coating unit. Second one, electron beam gun. Third one, DK2 ratio recording, Perkin Elmer spectrophotometer. Fourth one is the high temperature furnace up to 16,000 degrees centigrade. Fifth one is the transmission scanning electron microscope, TAM and SAM. Sixth is the sputtering unit. The following electronic instruments have been built and successfully used. There is a seventh one, temperature controller. Eighth one, liquid nitrogen cryostat. Ninth one, liquid nitrogen level indicator. 10th one, current constant current source. 11th, IC regulated power supply. 11th is CVD. 13th is PCVD, and 14th is the ALD dry witch and metrology. Okay, about my research work. I have built several electronic gadgets which depict the fundamental principles of physics under the category of low cost equipments. I have been very keen in the fabrication functioning of these gadgets at undergraduate and postgraduate levels. My research problem converges on experiments on the materials which are useful in the preparation of thin film solar cells. The effect of various deposition parameters on the electrical and optical properties will have to be studied. Apart from this, the influence of swift heavy ion beam irradiation on these films will be undertaken at Nuclear Science Center, New Delhi. The SHI is expected to modify the film by mixing due to thermal spiking or electronically by Coulomb explosion, which can be optimized for better material properties. Various measurements throw light on their structure and the nature of the film. This research will culminate by evolving better alloys or materials with optimal parameters for the preparation of thin film solar cells in order to increase the energy conversion ratio. The other part of my research problem is the synthesis of bulk and ceramic thin film for fabrication of devices. They are small in size. The performance efficiency of bulk devices manufacturing is rather low and erratic, and hence thin film ceramic devices and their behavior under various conditions or parameters is being undertaken in this research, wherein huge industrial applications can be later defined based on the results obtained. The importance of the present research work is to perform a systematic study of electrical resistivity, optical conductivity, and structural or morphology of ceramic samples. This throw light on transport carriers, their nature, their concentration, mobility, activation, energy, band gap, and optical transmitters, etc. These studies will help in fabricating and developing high conducting or non-conducting materials useful for several solid-state devices. The effects of composition, structure, and environment on physical properties in terms of atomic, ionic, and electronic behavior is the prime aim of the present research problem. Apart from this, the effect of deposition parameters of the physical properties will also be dealt in detail. Objectives. The main objective of this research is to carry out a systematic study of the impact that thickness has on optical properties such as the band gap, absorption coefficient, optical density, among others, for selenium thin films. The understanding of the band gap and its influence on the film thickness of semiconductor films. The materials and methods used are ultra purity 99.99%. Selenium was deposited on glass substrates. During deposition, the glass substrate on its respective support was rotated at a constant speed to obtain a uniform coating. Results and discussion of this research paper. The XRD findings indicate that selenium is amorphous in nature. It is found that the band gap of the optical band takes a descending shape, 2.3 to 2 electron volt, with increasing film thickness in the interval to 200 to 1000 nanometer. The band gap of the band obeys the inverse square law with respect to thickness. Now moving to the next slide. Conclusion: we have successfully generated selenium thin films below the de Broglie wavelength limit by vacuum thermal evaporation. The optical density varies directly with the thickness of the film. The absorption coefficients were located in the interval of 0.5 to 4 into 10 raised to 7 per meter. The AFM results confirm that the nanometric size of selenium increases with increasing thickness. Both grain boundaries and subgranular regions are clearly visible in some micrographs. That is from zero point 0.3 to 2 electron volt with increasing film thickness in the range 200 to 1000 nanometer. The band gap of the band obeys the inverse square law with respect to thickness. Conclusion: we have successfully generated selenium thin films below the de Broglie wavelength limit by vacuum thermal evaporation. The optical density varies directly with the thickness of the film. The absorption coefficients were located in the interval from zero point 0.5 to 4 into 10 raised to 7 per meter. The AFM results confirm that the nanometric size of selenium increases with increasing thickness. Both grain boundaries and subgranular regions are clearly visible in some micrographs from zero point 0.3 to 2 electron volt with increasing film thickness in the range 200 to 1000 nanometer. The band gap of the band obeys the inverse square law with respect to thickness. Conclusion: we have successfully generated selenium thin films below the de Broglie wavelength limit by vacuum thermal evaporation. Now, moving to the next slide. That is, the AFM results confirm that the nanometric size of selenium increases with increasing film thickness. Both grain boundaries and subgranular regions are clearly visible in some micrographs. We have successfully generated selenium thin films below the de Broglie wavelength limit by vacuum thermal evaporation. Okay. Now, title of my talk is on the topic that is natural resources. Now, please have a glance over this picture. That is the natural resources. We are going to discuss on the topic renewable and non-renewable sources of energy. So, what are natural resources? Resources that occur in our nature are known as natural resources. Means these cannot be produced by mankind. Examples: sunlight, minerals, and so on. Okay. Classification of natural resources. Natural resources can be divided into two categories. That is renewable resources, and second one is the non-renewable resources. First, we shall let me know what are renewable resources. Resources that can be replenished naturally in the course of time are called renewable resources. Okay. Examples: air, water, sunlight, wind. Means that can be produced uh, day by day. Okay. Next. What are non-renewable resources? Resources that exist in limited supply and cannot be replaced if they are used up are called non-renewable resources. Example: oil, natural gas, coal, nuclear fuels. If we use daily, then one day it will be exhausted. Okay. Please have a glance at this picture. These are the renewable energy sources. There is solar energy, hydropower energy. Energy means different forms of energy: geothermal energy, wind energy, biofuel energy, okay, and so on. And this is the non-renewable energy. Here, fossil fuels are present. Okay, natural gas, nuclear energy, coal. Renewable resources. There are different forms of renewable resources: solar energy, wind energy, hydropower, geothermal energy. Okay, this is the picture of the solar photovoltaic cells. That is solar energy. We can see this solar energy installed in different parts of India as well as in the world. Okay. Solar energy. Solar energy is the energy that is radiant light and heat from the sun harnessed using a range of ever-evolving technologies such as solar photovoltaic cells. The sun is a powerful source of energy that provides the earth with as much energy everywhere as we collectively use in a year worldwide. Energy from the sun is harnessed in two ways. First one, active solar involves capturing and redistributing sunlight through the use of solar panels, pumps, or solar fans to generate power, usually on a large scale. Second one, passive solar works to reduce the amount of energy traditionally used to power a location, such as a building or house. An example is building a house in the natural direction of sunlight to trap heat. This is the picture of the wind energy. You can see the windmills which are used to produce electricity. Wind energy. The electrical energy that is obtained from harnessing the wind with windmills or wind turbines is called wind energy. Winds are caused by the uneven heating of the atmosphere by the sun, the irregularities of the Earth's surface, and rotation of the Earth. Wind turbines convert the kinetic energy in the wind into mechanical power. Large wind farms consist of hundreds of individual wind turbines which are connected to the electric power transmission network. Have a glance over this picture. There is the hydropower. Means hydropower. They are constructed. Dams are constructed where the source of water is available in plenty. Hydropower is the energy derived from the falling water or running water. Falling water is channeled through water turbines. The pressure of the flowing water on turbine blades rotates a shaft and drives an electrical generator, converting the motion into electrical energy. But hydroelectric power does not necessarily require a large dam. Some hydroelectric power plants just use a small canal to channel the river water through a turbine. In Karnataka, we can see the hydropower generating station at KRS. This is the geothermal energy. You can have a glance at this picture. Geothermal energy, it is the thermal energy generated and stored in the earth. Thermal energy is the energy that determines the temperature of matter. The geothermal energy of the earth's crust originates from the original formation of the planet, that is about 20%, and from radioactive decay of minerals 80%. The geothermal gradient, which is the difference in temperature between the core of the planet and its surface, drives a continuous conduction of thermal energy in the form of heat from the core to the surface. The resources of geothermal energy range from the shallow ground to hot water and hot rock found a few miles beneath the Earth's surface and down even deeper to the extremely high temperatures of molten rock called magma. So now we shall discuss about the pros and cons of natural resources. Solar energy, its pros. It saves money. A lot of money can be saved as the money paid in the form of power bill will be reduced. Green energy. Pollution produced by the burning of fossil fuels like petrol, cutting trees for timber can be decreased to a greater extent. Cons, mostly mythical. There is upfront cost. Some people hold off on purchasing solar panels because they imagine that they can't afford the initial expense. But the amount spent on installing solar panels can be gained in a few years as they save on electricity produced from traditional sources such as coal, wood, etc. Maintenance. Homeowners unfamiliar with solar technology sometimes fear that complex repairs will be needed. In fact, solar panels have no moving parts, so there is no wear and tear. Rain is generally sufficient to keep the panels free from dust and grime. Okay, now moving to the next slide about wind energy. Its pros. Wind energy is a green energy source and does not cause pollution. The potential of wind power is enormous. It is nearly 20 times more than what the entire human population needs. The operational costs associated with wind power are low. Cons. Wind is a fluctuating source of energy and is not suited to meet the base load energy demand unless some form of energy storage is utilized. Example, batteries, pumped hydro. The manufacturing and installation of wind turbines requires heavy upfront investments, both in commercial and residential applications. Wind turbines can be a threat to wildlife. Example, birds and bats. Okay. Next, moving to the hydropower energy. Its pros. Hydroelectricity is very reliable energy. There are very little fluctuations in terms of the electric power that is being by the plants unless a different output is desired. Adjusting water flow and output of electricity is easy. At times where power consumption is low, water flow is reduced and the maximum levels are being conserved for times when the power consumption is high. Cause hydroelectric power plants may affect fish is a complex interaction between numerous physical and biological factors. Building power plants in general is expensive. Electricity generation and energy prices are directly related to how much water is available. A drought could potentially affect this. Now moving to the geothermal energy. No fuel is required for this, no mining or transportation, not subject to the same fluctuations as solar or wind. Smallest land footprint of any major power source. Virtually limitless supply. Cons. Prime sites are often far from population centers. Losses due to long distance transmission of electricity. Sulfur dioxide and silica are emitted. non-renewable resources. Example, first one oil, second one natural gas, third one coal, fourth one is the natural resources. Now we shall discuss the oil. You can have a glance over this picture. Oil, that is petrol, diesel and other forms. Okay. Liquid petroleum crude oil is the only non-renewable resource in fluid form. A fossil fuel that is being used up faster than new reserves are discovered. The oil supply may only last through the middle of this century. Industrial nations in the US far in the lead are the biggest consumers of crude oil. Gasoline, heating oil, and diesel fuel are the primary users of the resource, although manufacturers utilize oil as a base for such products as plastics and industrial chemicals. This is the natural gas. Natural gas, it is a fossil fuel formed when layers of buried plants, gases, and animals are exposed to intense heat and pressure over thousands of years. The energy that the plants originally obtained from the sun is stored in the form of chemical bonds in natural gas. It is primarily composed of methane but contains ethane, propane, and butane as well. Once drillers extract natural gas, processing plants remove the propane and butane for use as liquefied petroleum gas, popularly known as LPG, is a household and industrial fuel. According to the current usage statistics and the volume of world reserves, the supply of natural gas should last another century. This is the coal which we see in our daily life. Okay. Coal, which is a primary resource of energy in India, is a product of millions of years of pressure on original organic matter from plants buried underground. It is a combustible black or brownish black sedimentary rock, usually occurring in rock strata in layers or veins called local beds or coal seams. Anthracite, the purest form of coal, contains about 94 to 95% of carbon. At, at the power plant, coal is commonly burned in a boiler to produce steam. The steam is run through a turbine to generate electricity. The global supply of coal, given the current rate at which it is used, should last at least two more centuries. Now, we shall discuss the nuclear energy. These are the nuclear reactors which are uh, located in India as well as throughout the world. In India, we are having the Kaiga nuclear plant. Nuclear energy. Nuclear power or nuclear energy is the use of exothermic nuclear processes to generate useful heat and electricity. The term includes nuclear fission, nuclear decay, and nuclear fusion. Presently, the nuclear fission of elements in the antecedent series of the periodic table produce a vast majority of nuclear energy in the direct service of mankind. In nuclear fission, neutrons smash into the nucleus of uranium atoms and release energy in the form of heat. Water is converted to steam by this heat and it is used to drive the turbines. Nuclear fission power stations, excluding the contribution from naval nuclear fission reactors, provided about 5.7% of the world's energy and 13% of the world's electricity in 2012 is nuclear energy. Now moving to the steps taken for conservation of natural resources. Various resources is needed only when it is required. Avoid the wastage of resources. Avoid the use of material from wildlife sources. Use energy sufficient electrical appliances. Use pressure cooker for cooking, which saves 75% of the LPG used in homes. Old vehicles should not be used as they are less fuel efficient and also cause pollution. Utilize renewable energy sources as much as possible. Increase use of solar cooker pump, etc. We should recycle the waste and waste water for agriculture purposes. Thank you for giving me an opportunity.